Hello friends, welcome to this platform. My name is Sanjay Best and I love physics, especially the mind-boggling and fascinating concepts involved in physics. So today I would like to discuss one such concept. Let us imagine that this is an imaginary surface and there are static charges around this surface, and this is an empty space. Now because this is an empty space, so there is no charge in the space. Now let us apply Gauss law on this surface. This is Gauss law. Q in is 0, so cyclic integral E dot dA will be 0. Now let us redraw this picture here. So this is the imaginary surface now, and this is the point P. What I am saying is that if there are static fields, if all the charges are static, then there cannot be any point here which will be in stable equilibrium. So there cannot be any point in stable equilibrium in electrostatic field. So imagine that this is a point, and if this some charge here is in stable equilibrium, then the electric field around this charge should be pointing towards the point P. Because if I put a charge here and displace this charge in this direction, so the electric field must be able to push this charge back to this point. Then only this will remain in stable equilibrium. So if the electric field around this charge is pointing towards this point, all the electric field vectors are pointing towards this point, and now we apply Gauss law, then we can see very easily that if the electric field is in this direction, and here the area vector is in this direction, then the angle between the field vector, electric field vector and area vector is definitely more than 90 degrees. So the dot product will be smaller than 0. The dot product will be negative. So cyclic integral E dot dA must be negative, which will be violating Gauss law. So this charge cannot remain in stable equilibrium. So this is what I wanted to stress upon, that in an electrostatic field, no charge can remain in stable equilibrium. Thank you very much. I hope that you enjoyed this interaction. Have a nice day. Bye.